In development from birth to adulthood, there are daily tasks that are learned and repeated. Whether it is learning to crawl, cite the alphabet, math, driving, or finding car keys, how do we know to remember how to do these things? According to Badley, working memory is defined as a limited capacity workspace for the temporary storage and simultaneous processing of information. Higher cognitive functions or intellectual abilities have been predicted, such as mathematical skills, reading, and intelligence. Eng and Lee conducted an experiment where they used spatial short-term and working memory tasks that impose similar demands on executive resources. Spatial short-term memory, also known as short-term spatial memory, STM, the storage and retrieval of information within the brain that is needed, is both to plan a route to a desired location and to remember where an object is or where an event has occurred. Environmental factors are associated with STM. In this experiment, the working model of memory theory was used to show how each component works independently on each other for short-term memory.
We predict that the statistical means for each age will differ. As children become more developed, this task will be easier to complete. When being timed, the children's overall averages will decrease as the child's age increases. Visual memory of stimuli will become increasingly difficult the less developed the brain is, which relies on our prediction that the means will decrease in seconds as the age of the child increases. Statistically, the 8-year-old and the 11-year-old throughout our study spotted differences on visual stimuli with a higher mean over the 3-week-long testing period than a 4-year-old. Over the 3-week-long period of testing, the 4-year-old did not recognize the differences at a similar rate as the 8-year-old or the 11-year-old, who recognized the differences much quicker. The rates differ by significant times, mainly because the 4-year-old who had excessive difficulty with the task in Test 1. Though the first test done to the 4-year-old was redone for more accurate results, which led to an accurate mean for the results of the 4-year-old. The results will be discussed in more detail throughout the results section, and each child's statistical mean of seconds to find the differences will be discussed in detail as well. The means of each child finding the differences in the photos decrease as the age of the child increases.
Hi, my name is Chantal Sanchez, and I did the methods section of our research project for visual memory. We had 3 participants, 1 girl and 2 boys, whose ages ranged from 4 to 11, and we were provided verbal consent from their parents to participate in the study, and each session lasted about 5 minutes. For the stimulus, for the materials that we used, we had a spot the difference templates that we found online at supercoloring.com and Pinterest, and depending on their age is what determined which template they were showed. And each session was recorded on a Canon camera and was timed by a OneNote Plus smartphone, regular timer app. The study was conducted on 3 different dates: October 28th, 2019, November 4th, 2019, and November 11th, 2019 at 5 p.m. Mountain Standard Time. Like I said before, depending on the age of the participant, that determined which template was shown to the participant. The 4-year-old was shown find the 5 differences, the 8-year-old was shown spot the 10 differences, and the 11-year-old was shown spot the 15 differences. For the 4-year-old, we had to give her an example before giving her the actual test, and the example kind of helped with her learning what differences were and seeing that there was differences in the 2 pictures that we were showing to her, and that she could find them later by herself on the actual test.
So you might explain it a bit more.
Okay, I'll let her circle it first.
Okay.
We're gonna start over. Okay, so you're gonna look at this picture and look at this picture and tell me what the 3 differences are, okay? And you're gonna circle them. Difference, right? And how you have a headband and I have a ponytail, that's a difference, right? So we're gonna find the differences on this page, okay? And I'm gonna time you, okay? So I'll find a difference first. So like, you see how there's no leaf here? And there's a leaf there? That would be a difference. So you'd circle that. And then you see how there's dots in this flower? And there's dots in that flower? That's the same. But there's dots in this flower, and there's no dots in this flower, right? So that would be a difference, okay?
Is the pen not working? No. Oh, okay.
The activity of finding the difference was applied in order to measure in children their ability to find the difference in a specific time. They were given 5 minutes, however, it was detected that for 4-year-old girls, this task was difficult, while for the children of 8 and 11 years was relatively easy, where we found what they were asked for within the allowed time. However, there were no changes between the second and third tests. The first test was measured only in 1 week, and in that time there is no change with respect to visual memory.
In conclusion, we could see that since the instructions were not well given from the beginning, the 4-year-old girl did not understand what she had to do and therefore was not able to find the differences between the two images. She had to be supported and do the activity together with the psychologist so she could understand. Also, the stimuli were not adequate. The youngest was in a room with noise, where the table reached very high and could not see easily. In the second attempt, the girl, knowing what the activity was about, was able to find the 5 differences as in the third attempt. With respect to the 8-year-old boy, having already learned about this activity, he was able to understand that he had to find the differences, and he did it during the 5 minutes. However, he did not have time to find the 10th difference. The 11-year-old boy was able to find the 15 differences by himself and without help in the 3 attempts. We can conclude that the time of the experiment was 3 weeks. Therefore, there were no significant changes in the children's visual memory. Only from the first to the second experiment, because the children did it with more speed, since in the second test they already knew what they had to do, which was to look for the differences. Thank you, Universidad Anáhuac Puebla and Eastern New Mexico University, for the opportunity to work together to carry out this research.